We're now looking at our hyperbola, which has been translated around a little bit. And we know that because when we have a look at the equation, we've got these pluses and minuses in brackets up here. So let's have a look at the general equation for a hyperbola, which has been moved. And it'll be x minus h squared over a squared minus y minus k squared over b squared equals 1. Now you'll notice something else then, and that is that my y term here is first and my x is second. That means that when I put in my hyperbola, the hyperbola itself is going to be above and below the asymptotes, and not to the left and right. That's what the y being first does. What we need to do then is have a look at what our translation will be, draw our asymptotes, and then work out all our intercepts and equations. So here, this y minus 2, the y minus 2 means that I've translated up by 2. The x plus 1 means that I've translated left by 1. So therefore, I can put my asymptotes in, and they're going to intersect at -1 and 2, somewhere around here, let's say. The next thing I need to do is work out the equations of my intercepts. In much the same way, the equations of the asymptotes for a hyperbola centered on the origin is y equals positive or negative b over ax. The equations, once we've moved it, are y minus k equals positive or negative b over a x minus h. So then we need to get our b's and a's and make sure we write this so that we can find the equations of the asymptotes. That means this will lead us to asymptotes will have the equation y minus 2 equals b over a. Now remember, b is the square root of what's under here. So b will be 3. A is the square root of this term, which will be 4. And then I'll have x plus 1. We can borrow the minus 2 and plus 1 straight from the top lines in our equation. Now we have to use algebra to find the equations of our asymptotes. So we're going to add 2 to both sides. And then we're going to split this to deal with the positive and the negative. So one of our asymptotes is going to have the equations y equals 3/4 x plus 3/4 plus 2, which gives us y equals 3/4 x plus, that'll be 11 over 4. And the other asymptote will have the equation y equals negative 3/4 x plus 1 plus 2, which will give us negative 3/4 x plus 5 over 4 once I expand and collect. So let's draw these two asymptotes in. One of them is going to look like this. One of them is going to look something like this. Our equations will be written down here. And make sure we get that correct. And then we can put in our hyperbola. We know our hyperbola is going to be above and below, so that means we can draw that in, something like that. And same with the one that's going to be below. And then we have to work out our intercepts for the hyperbola. So remember that my y-intercept is where x equals 0 and vice versa. So my y-intercept will be where the equation is y minus 2 all squared over 9 minus 0 plus 1 squared over 16 equals 1. And then we need to algebra our way through this. y minus 2 squared over 9 will equal 17 over 16. We'll multiply both sides by 9. And I think that'll be 153 over 16. We'll take the square roots, and remember, we need to positive and negative that. So 153 over 4. And then we need to add the 2. So y will equal 2 plus or minus root 153 over 4. And that will be this point and this point. My x-intercepts will be done exactly the same way. I'll allow y to equal 0, and then I'll establish where my two x-intercepts are. One final point to note is for this point here, a point something like this, we need to be super careful that we have it on the right side of the origin. If these numbers are positive, then I need to make sure my hyperbola exists above the origin. If the numbers for the intercepts are negative, then I need to make sure the hyperbola exists below the origin. Just make sure you do that and you'll get the graphing right every time. If you found this video helpful, please subscribe or like. Thanks.